We're going to do the final part that we have for vectors, starting with dot product. Your dot product is basically multiplying your vectors. So say you have vector u times vector v. The way that we are going to do dot product, you take the x value of u, multiply it to the x value of v, and then you add the y value of u times the y value of v. This will give you some number answer. The dot product is going to be like 5 or 12. It's not going to be an x value and a y value. It'll just be one number. The other thing we're going to be solving is the angle between two vectors. When we're solving for an angle, we use theta. The angle between two vectors is going to be cosine inverse because we're solving for an angle. And then you take the dot product in the numerator divided by both magnitudes. So the magnitude of u times the magnitude of v. So when you find the angle between, if you already have the dot product, you just plug that number in the numerator. So let's practice doing these two things. Example 1. Here's our two vectors. We're going to find the dot product and the angle between. So if I'm going to find the dot product of u and v, I do x times x plus y times y. So both x values are -1 and 2. So I'll do -1 times 2 plus 4 times 5. So I multiply x and x plus y times y. So let's do that. This will give us -2 plus 20. So the dot product is 18. Cool. All right, now let's find the angle between. For the angle between, we're going to take theta equals cosine inverse. I already found the dot product. I know it's 18, so I'll just say 18 in the numerator. And now we need to look at their magnitudes. Remember, magnitude is like Pythagorean theorem, where you take the square root of x squared plus y squared. So first, let's look at u. So I'll do -1 squared plus 4 squared times, do the same thing for v, its magnitude, 2 squared plus 5 squared. Okay, let's simplify that a little bit. Cosine inverse, I'll leave 18 square root. Okay, 1 squared is 1, 4 squared is 16, so this becomes 17. This is 2 squared is 4, 5 squared is 25. That'll be 29. So this is what I'll type in the calculator. So you're going to type in your calculator or Desmos or wherever you do your calculations, cosine inverse of 18 over root 17 times root 29. Now, an issue that some people have when typing this in the calculator is they forget to arrow over out of this first square root, and they end up extending this square root over the second one. So make sure after you type in square root of 17, you kind of arrow over before you press multiply. Okay, and if you type that in, you should get 35.8. That's your angle between those two vectors. I would recommend, please practice typing this in. Once we get to the test, I'm not going to tell you the answer. You need to know how to type it in. All right, let's do it again. So on example 2, we are doing the same thing. They want us to find the dot product and the angle between, but this time they give it to us in linear combination form. That's okay. It means the same thing. It's just written a different way. So if we're going to find the dot product, the x here is 5, the x here is -3. So 5 times -3 plus the x here is just -1. Over here, it's -7. Cute. So that'll be negative 15 plus positive 7. Add those together, you should get negative 8. Okay, there's our dot product. Let's go to angle between. Cosine inverse. Dot product is negative 8 over, let's do their magnitudes. So 5 squared plus negative 1 squared is 25 plus 1 is 26. 3 squared is 9. 7 squared is 49. 9 and 49 is 58. We're typing this in the calculator. Please practice typing it in and check that your answer was 101.9. Please pause this video while you practice typing it in to get 101.9. Wow, welcome back from typing it in. Okay, that was dot product and angle between. Now we're going to look at some new terms, or I guess one new term. The only new term we'll have is orthogonal. Orthogonal just means perpendicular when you're talking about vectors. If you have two vectors and they are orthogonal, aka perpendicular, what is their angle between them? Remember, perpendicular lines look like this. So the angle between them would be 90 degrees. So if we are going to find vectors that have an angle of 90 degrees, that means their dot product was 0. Okay? So that's how you know two vectors are perpendicular, if their dot product is 0. So we are going to be using this to verify. The other thing we're going to look for is if the vectors are parallel. So instead of looking like this, they look like this, right? We all know what parallel and perpendicular are. Parallel and perpendicular happen, perpendicular happens when the dot product is 0. Parallel happens when there is some scale factor going from vector u to vector v, or first vector to second vector. So they use k as their scale factor. Now remember, your vectors have an x and a y value. So to be parallel, you have to use the same scale factor from x to x as you do from y to y. So to look at each of these vectors, we're going to look to see if the dot product is 0 or if they use a common scale factor. If they don't do either of those things, the answer will not be parallel or orthogonal. It will be neither. So let's take a look-see. On part A here, we have 2, 4, and negative 2, 10. The first thing I like to check for is parallel because that's going to be less work. And if I can stop there, then that is so great. So first I check x to x. 2 to negative 2 is just times negative 1. Let's check if you do that same thing to get from y to y. Is 4 times negative 1 10? No. So they are not parallel. So now we need to check orthogonal. I need to check their dot product. So I will do 2 times negative 2 plus 4 times 10. I know this is negative 4 plus 40, and that is not going to equal 0. So it's not parallel, it's not orthogonal. That means our answer for this problem is neither. Cool. Questions? Okay, great. Let's look at part B. So part B, again, I'm going to check for parallel first. So 5 to negative 16. I don't know off the top of my head what that scale factor is. So what I'm going to do is go in my calculator and do 16 divided by 5, then see what they're multiplying by. When you do that, you get negative 3.2. So now I need to check, is 8 times negative 3.2 10? See if they use the same thing. Well, guess what? They do not, because 8 times a negative number isn't going to give us a positive 10. So now let's check their dot product to see if it's 0, to see if it's orthogonal. So I have 5 times negative 16 plus 8 times 10. 5 and negative 16 is negative 80. 8 times 10 is 80. Oh my gosh, that's 0. Therefore, these are orthogonal, aka perpendicular. Woohoo! Okay, last one. Again, the first thing we're going to do is check to see if it's parallel. To get from negative 5 to positive 1, that is multiplying by negative 1/5, aka dividing by 5. Is 15 divided by negative 5 negative 3? Oh my gosh, yes it is. These are parallel because their scale factor k was negative 1/5. They divided both x and y by negative 5. Cool. Okay, we have a couple more practice problems on this last page. We have 2 where I want you to find the dot product and 2 where I want you to tell me parallel, orthogonal, or neither. What I want you to do is pause this video and try these 4 on your own. Figure out what you can do without any help, and then we'll check our answers. So go ahead and pause. Make sure you pause. Did you pause? Great. Welcome back, everybody. Okay, let's check our answers. So, dot product. What you should have done is 3 times 6 plus 9 times 5. That gave you 18 plus 45. The dot product is 63. Did you get it? Good job. This one, you're doing the same thing. It's just in linear combination. Let me switch it for you. If you don't want it to be in linear combination, this is 1, 5. This is negative 6, negative 2. So still following the same process. You'll do negative 1 times negative 6 plus 5 times negative 2. 6 plus negative 10 is negative 4. You got that? Good job. Okay, for this one, parallel, orthogonal, or neither. To get from 4 to negative 9, do you use the same scale factor to get to negative 9 to 4? No, these are not parallel. Let's check their dot product. These are both what? Negative 36 plus negative 36. That does not equal 0. So these are neither. Okay, this one. To get from negative 5 to negative 10, that is just times 2. Is negative 2 times 2 positive 25? No. So let's check their dot product. Negative 5 times negative 10, negative 2 times 25. That's positive 50. That's negative 50. That equals 0. Oh, hi. Excuse me. So these are orthogonal. Wow, did you get all those right? Yay! Give yourself a high five. This bottom section is some word problems. We don't have time for that, so we are going to skip the word problems this unit. And that is everything you need to know about vectors. See you later.